This problem tests whether the students are very familiar with some laws about a circle. So let's look at this circle and one of the triangle inside it. So how can we know at least one interior angle is 45 degrees, this alpha? Or when can we get an interior angle of 45 degrees? To solve this, you have to be very familiar with the properties of a circle. For example, do you know the inscribed angle subtended by a diameter is always 90 degrees? Or do you know the central angle is always twice the inscribed angle that subtends the same arc? Or the inscribed angles are the same when they subtend the same arc. For example, here, the angle ADB is the same as ACB. They both is half of the central angle of AOB. So please remember these 2 points we would need it to solve this problem. So let's look at, continue. To get an inscribed angle of 45 degrees as the text required, that means an interior angle is 45 degrees, we can try to get a center angle of 90 degrees. Since this circle was divided into 12 arcs, it means that the central angle corresponding to each arc is 30 degrees. In order to get an inscribed angle 45 degrees, and we can get 90 degree central angle by corresponding 3 small arcs. According to rule 2 in the last slide, the same arc will correspond to the same inscribed angle. So which means here there's 45 degree, and here 45 degree, here's also 45 degree with this point, and also here's 45. How many of them? 1, 2, 3, 4, 5, 6, 7, 8. So which means when we start from the point of A, and we can get 8 triangles which has at least one interior angle that's 45 degrees. How many points like A? We total have 12 points like A. So we have 96. But let's look. This triangle is a special one. So because from those triangles whose bottom is a diameter actually were counted twice. So why? Because if you look at from A, and A6B was counted when we look at A points. But when we look at B points, that A6B happened again. So it's a completely identical triangle. And we counted when we use A, 8, and when we use B again, we count it. So we have to divide each point. We count twice that one, those which one, the triangle whose bottom is a diameter. So that's 12 of them, 12 diameters. Therefore, we minus 12. In the end, we have 84 triangles, which are unique triangles whose at least one interior angle is 45 degrees.